OSM offers a method for smoothing the data, which is a combination of Gaussian filter and visibility. I'm going to use a very simple example in here to show how it works. So I'm going to quickly set up the environment first. And let me create a layer of data with the polygon method. And if you take a look at this data in its current shape, you will see that it's very simple. We have value of 10 for here and the value of 0 for the rest of the floor. And if I want to make this data smooth, uh, I can probably use a Gaussian filter, but that's not going to be a very good idea. It's because when we use a Gaussian filter, we are actually creating something like this to create weighting factors. This is a normal distribution. And if you're using a normal distribution, you're calculating the weighting factors, and then you would be averaging each of these cells with the weighting factors of the cells around it. And but if we are going to do that, then we would be expecting the value on the other side of the wall to be also influenced by the value in here, which is much higher. But we don't want to do that because visibility is also a factor in here. So we don't want uh, the weighting factors to influence the visibility. So for that, we would be actually filtering the Gaussian filter. We would be clipping the Gaussian filter with the field of visibility. This is a special kind of data filtering that I developed, and I integrated that inside the software. And let's take a look at how it works. So we have data one field here. This is a Gaussian filter which will be clipped with the visibility, and we will need to create the Gaussian filter based on neighbors. I put neighbors as a way of creating Gaussian filter because of consistency with other methods that use the neighborhood size. And the way that the neighbors are working is that you will be entering the number of cells, and then um, uh, the the parameters of the Gaussian distribution will be calculated in a way that after that range of neighborhood that you have calculated, the weighting factor is almost zero. Almost zero, I mean smaller than 10 to the power of minus 5. Let's put a larger number in here, and let's give a name to this filtered data that we would be creating. This may take a while to be calculated because it uses visibility analysis. And now if we take a look at the filtered layer of data, we will have a better understanding of what it does it mean to combine visibility with blurring. You will see that the other side of the wall, which is not visible from this side, is actually not influenced by this side as well. So if you take a look at that in 3D environment, it would be even better. So this is our data. This is our data, which is not as smooth and very simple, and we have a wall in here which uh, which will block the view from one side to the other side. And if you take a look at the filtered data, you can see that the wall is still affecting the way that the data has been filtered. So if you go to the other side of the wall, you will see that there had not been any changes applied.